I suppose the question is, who is Satoshi Nakamoto? Now, I've heard a bunch of different theories that Nakamoto is the Central Intelligence Agency, that he's a collective of cypherpunks that decided to get together secretly and build Bitcoin. I've heard the theory that it's a natural progression from eCash and DigiCash, that the developer of those moved on, taught a student, and that's how it happened. All of the different characters involved in this, I'm not going to name them specifically because I don't think there's any value in naming anyone and pointing fingers. People can go and find out the important parties' names and harass them however hell they want to without my adding fuel to that fire. People's lives have been ruined already through speculation. One thing we can assert is that Satoshi Nakamoto is a ghost. He has left no trail of evidence behind to find out who he really is. Pretenders may pop up from time to time. Theories might emerge, dozens of YouTube videos, all proclaiming to know the answer, but it still remains just idle speculation. If we think about Satoshi in terms of his skills, he possesses an incredibly diverse set of skills. He understands cryptography, he understands economic theory, he understands how to remain anonymous to such a degree that even the world's intelligence agencies, the High Court, no one can find him. He's invisible. He's also a reasonably proficient C++ programmer, capable of building cryptographic algorithms with existing tools fairly quickly. If we pool analysis of the timestamps where posts appear online, or comments are made, or emails are received, and we build a histogram of that data, we find an interesting sine wave. It suggests a time zone somewhere in the American continent, if we assume a normal sleeping period. Outside of the sleep cycle, it's very difficult to identify any kind of routine or pattern. There's no dip for lunch times, there's no dip for when he has to go and collect the kids from school. It seems very much that he's some kind of a reclusive obsessive that focuses entirely on Bitcoin and doesn't have time for anything else. Now, many people in the past have been reclusive obsessives. A lot of mathematicians have been reclusive obsessives. There's no doubt that focusing entirely on a complex problem is something which can consume somebody's entire life. But there's being a reclusive obsessive, and then there's being somebody who's obsessively anonymous. I'm not sure that these are entirely the same thing. The measures that Satoshi took in order to maintain his anonymity start at the very beginning. The acquisition of the domain name is done via a prepaid credit card, possibly initiated with a cash transaction. The website anonymousspeech.org is run out of Japan at the time by a guy who's largely providing domain names to various kinds of pornographers and organized criminals. The earliest email contacts which appear to exist also come from anonymousspeech.org, but it's unlikely that the operator of Anonymous Speech was involved in any way in the design or creation of Bitcoin. Obviously, the further we go back in time, the less evidence we're likely to find. But this focus on anonymity appears to have been consistent from the very beginning. What this suggests, more than anything, is that it was all intentional, that the creation of the character, Satoshi, was intentional, that the timed release of Bitcoin shortly after the character was created was intentional, that a peripheral involvement from Satoshi persists and continues while others in the community take over and develop Bitcoin as an open source project. The handoff of the domain name and various other actions which Satoshi had taken indicate that the invention of the character, the anonymity, the handoff was part of a plan. Planning requires foresight. To some degree, you could say that whoever Satoshi is had some understanding of the outcome that would eventually occur as a result of his contribution. If we take the time to look at the way that Satoshi writes, we can work out that he's probably got a PhD. He's got a good understanding of computer science, economics, cryptography. His writing style uses British spelling, but with an American grammar and American formatting. He says in one of the emails that he's not very good at writing, and if pushed, he can provide answers to a FAQ for a website. So he's not interested in building the marketing, the brand, or even getting rich, or building an identity around himself and what he's created. He has no desire to take any credit for what he's done. Just to be there, to shepherd it through the first few stages, and then suddenly, as quickly as he appeared, to vanish. Then there's this long 3-year gap. The final email that appeared was to declare that he wasn't Dorian Nakamoto. This was as a result of the press hounding Dorian, basically ruining the guy's life. So that final email was sort of a kind farewell. So the Satoshi identity is such a hot topic that anyone who could possibly be connected ends up being hounded, or, I mean, a few people involved have died. We can look at the reason that the Satoshi identity is such a serious issue. First of all, the amount of money that we're talking about is really serious. Organized criminals will be wanting to get a piece of it. If somebody could put a gun to his head and tell him to transfer $1 billion, you know, they would probably try anything. Then there's Wall Street, CIA, US Treasury. The number of people who would, at this point, put a price on Satoshi's head, it becomes a who's who of rich and powerful people around the world. As of today, Satoshi Nakamoto's wallet is worth $115 billion US. That amount of money would put him in the rich list of the richest people in the world. It's assumed that because that wallet has never been accessed, that the coins have never been transferred, that Satoshi Nakamoto has lost access to that wallet. Theories put about include that the wallet was split between 3 people, and all 3 are necessary to unlock it, and 1 or 2 of those people are now dead. Other theories have been proposed about the provenance and the fate of those 1.1 million bitcoins. The belief that those bitcoins can't be moved contributes considerably to the value of Bitcoin. Satoshi even makes a note about how when wallets are lost and Bitcoin vanishes, that just increases the value for everybody else. But the kind of money we're talking about $115 billion worth of essentially a commodity is enough to classify it as a weapon of mass destruction. That this cryptographic bundle of Sudoku puzzles is enough money to severely damage, if not completely destroy, the global economy. And the money doesn't even have to be used. It doesn't even have to be withdrawn. As soon as some of that Bitcoin is transferred out of that wallet, the entire economic landscape begins to change. Speculation and fear take over the market, uncertainty, and eventually panic and collapse. That's a lot of money, and it can be moved to any exchange which supports it, and those exchanges can be drained. That there isn't enough cash in the world to cover it without making the rest of the world suffer. Satoshi Nakamoto's 1.1 million bitcoins is an economic weapon. In order to understand how Bitcoin became so powerful, it pays to understand how the blockchain works. An immutable public ledger, which is shared and agreed upon by every node which can transact currency, enables people to make direct peer-to-peer transactions without a third party validating or guaranteeing the value of the currency. It's to decentralize banking. It's very clever in the way that it's built and the way that it avoids double spend using proof of work and various other cryptographic mechanisms, including the way that blocks point at the previous block in the chain, and this is why it's called a blockchain. This is relevant. Other blockchains exist. Git is a great example of a blockchain where changes in the historical record of adjustments to source code is retained. It's a perfect, simple little blockchain. It has divisions, it can branch, it can merge, it can do all of these things, but it is a chain of blocks which point at the previous block. An important piece of technology in many ways, and when it's paired with cryptography, it adds extra elements to that. Certainty of the people who are involved in making those changes to the source code in the case of Git. But with Bitcoin and the idea of blind signatures and other cryptographic technologies, you come up with a system which allows anonymous transactions to occur, as well as transactions which can occur without a central bank. And an anonymous public ledger is an interesting and powerful tool. Cryptographically speaking, economically speaking, it's a different kind of money. And it works. It's been proven to work now. It's not perfect, but it works. If we look at the years around the release of Bitcoin and what the world was like in 2006, 7, 8, we were just starting to see new kinds of computer hardware moving up and competing with the architectures of old. And what I'm talking about is the programmable pixel shader pipelines, which came out and revolutionized computer graphics. NVIDIA largely responsible for that. And from that first initial step, the graphics cards became more computational devices. In 2007, CUDA was released, and since multiple different technologies built on top of this now. But in 2007, CUDA was revolutionary. It allowed you to run incredibly heavy computational tasks at home on a consumer graphics card. It changed the high-performance computing landscape just a little bit. Around 2006, there was an implementation of a neural network on an ATI Radeon graphics card using a compute shader of some kind. They were able to get 10,000 times the performance of the CPU running through the graphics card. A major milestone. The first time that it was possible to, without extremely powerful supercomputers, realize the potential of deep learning and multi-layer backpropagation in a sensible form of large-scale data sets. These things were always constrained in the past by the size of the computers that the people who researched these things could get access to. And now, suddenly, there's this enormous layer of computation unlocked, originally designed for one simple thing: to increase the enjoyment of people playing computer games. And this is going to pop up again. Computer games are relevant, simulations are relevant. The design and architecture of simulations, game engines, and things of that nature are going to become more obviously relevant as I continue to unload this story. It has many facets, and it's difficult to cover all of them at the same time. So it may seem like we jump from place to place as we go on our journey together. But I'll try and make sure that we end up at the same destination. So just at the birth of Bitcoin, we're seeing these new ways of processing large volumes of data using graphics cards. Graphics cards have been designed and refined to process large volumes of data, do immense amounts of linear algebra quickly through the shaders, and then spit out pixels as fast as they possibly can, with no thought whatsoever to whether or not everything's perfect. But as long as it's good enough that it fools the eye, that's good enough for us. As GPUs moved towards this more general purpose application, Adobe Photoshop ended up with acceleration, video processing, decoding, encoding ended up with acceleration. The number of different companies and software products which incorporated this new technology, making them go faster, making them do more, enabled that technology to mature. And parallel with this maturation of the GPU technology and the APIs which we use to do compute, there was a parallel rise of the ability to perform high frequency hashing on those GPUs, to build enormous data centers full of GPUs for one purpose: to mine Bitcoin. So by 2009, CUDA-based neural networks were starting to win competitions in image recognition prizes, competitions which had seemed for decades to be out of reach of machines, suddenly fallen like dominoes. Parallel to enormous investment into buying outright palletfuls of NVIDIA hardware, putting it together in ramshackle data centers with one intention: hitting a jackpot, 50 bitcoins, and move on. The number of GPUs that NVIDIA had sold and the speed in which they would burn out if they were put on the task of mining Bitcoin continuously created an enormous updraft of income for NVIDIA. So much so that their stock price is probably 100 times what it was when this started. Now, we live in an era of data centers full of NVIDIA GPUs computing linear algebra at a scale that 10 years ago people couldn't really have imagined we could run numbers through machines. And those GPUs are learning how to be better large language models, better image generators. Those graphics cards designed for kids to play video games are now able to think for themselves in some way. I don't suggest that it's perfect or remotely human, but they're beginning to wake up. This is an interesting collaboration between the greed of human beings driving the adoption of a new kind of hardware, financing the adoption of a new kind of hardware, and that new kind of hardware being repurposed for doing other things, powerful things. This has put us on the shores of a great paradigm shift. It's probably going to trigger world wars, economic carnage across a wide scale. The labour market will collapse, the knowledge worker market will collapse, as artificial intelligence powered by NVIDIA's GPUs starts to become part of every day of our lives, everything that we do. We lose more and more control, we give it more and more energy, we allow it to use more and more of our resources, and if we think back, this probably wouldn't have happened if we didn't have data centers full of NVIDIA GPUs mining Bitcoin. That there were steps that took us there bit by bit, and those steps have been accelerated by Bitcoin. This sort of neatly brings us to the end of a 23-minute long episode, which is probably about the length that I want to keep each of these episodes, both to retain people's attention, but to not overwhelm people with the amount of information that needs to be digested, and to give some time to digest that information. Thanks for listening.